Hello, everyone. So this is the second short lecture on understanding machine learning. We'll discuss about learning process and data. So this is very, very important for us to understand that how we can just see that machine learning, the process works. Most of the machine learning models we discuss when we discuss, it's about supervised learning. We in the previous lecture, we mentioned that machine learning, supervised learning, like there is a teacher or supervisor or a coach, you are learning based on level data. There is unsupervised learning, and there is semi-supervised learning, and reinforcement learning, and so on. Okay, so more things are coming. But in this lecture, we'll try to understand machine learning process and data, but you will find that the examples are basically related to supervised learning. Just look at this, without understanding too much about this. So this child is having ASDs like autism spectrum syndrome, and this is typically developed child. Okay, so say here this image, and there are many, many kinds of loving thousands of image we feed. So data pre-processing and augmentations are important in machine learning or deep learning. So for example, if the images are of different sizes, we may need to resize them with a specific size. We may need to flip them or rotate them, or if there is noise, to remove the noise to make it better. So this kind of pre-processing, augmentation, like changing, or cleaning, the processes are needed. And then we can go for feature extraction. It can be handcrafted features, but classically we did, but if you use deep learning, deep learning based methods, then traditional feature extractions are usually not needed. And then what happens that whatever, deep learning methods or machine learning approaches we consider, it provides us one of the two decisions. So whenever, ASD or TD, so we have a binary decision and so on. So we have the true levels. True levels means the ground truth. So it means that, this image is ASD. So the output is ASD. We know. So whatever results we get, we compare with the true levels. So the predicted levels are compared with the true levels, and based on this, we update the weights and improve the method. Now, when we do like this way, it's just like training. So say this is an image. I am the model. So Atik model is saying that, oh, this is an ASD. This image means the image represents ASD. Fine. So we check the true levels, and it also says ASD. So it means that Atik did very well. So one. Now, the second, another image is TD, typically developed child, and then output is ASD by mistake because the input is TD. So it's a wrong thing, and my result is poor. So then what will happen that you are teaching me the loss is different, and then based on this, the feedback mechanism, and slowly, my learning, Atik model's learning becomes better. So then when uh, you say that the boss or the master, the coder, can say that, okay, your training is enough. Now go to the field. Okay, I send you to the war in real life. In the real life, now there is new image called testing data. We do lots of things, and finally, the trained model will give just an answer, one of those. It might be right, it might be wrong. So this is a real life situation. Like when we use AI models in our mobile phone, like Siri, when we talk to them and say that, okay, please call pizza, but it understood because of my accent that call Peter. And then it's calling Peter, and my pizza is never delivered like this manner. So it means that I am now testing the system. It may perform well, perform poor, based on the trained model we have already. So it you can consider that this is a kind of like, I mean, you are in the production, your AI model is ready to fight in the real life. All right. So we'll see. So what is machine? As I mentioned in previous lecture that we have this YouTube lecture, AI, what is intelligent machine? When we say the ability of a machines to perform task in AI, so what do we mean by machines? So machines, you can have a look. And learning, how do we learn? So machine learning is just like a friend, very raw sentence if I say that it's just like a friend who learns your preferences and gets better at recommending things. So you can say that this is sort of machine learning or teaching computers to make decisions based on data and patterns. See, this machine learning example and this machine learning example looks like supervised machine learning, isn't it? But as most of the machine learning concepts are based on supervised learning, so you find that many cases we compare like this way. All right. Now, data. Okay, this is extremely important. And when we have lots of data, the training is important. In my previous lectures, we discussed about data and the importance of training. Now, assume that there is a robot called Atik robot. Okay, so this is your friend Atik. I become a robot, and what I need to do? I need to be trained on large amount of data. So when you make me, my brain, which is just a computer system or something, okay, it's, I mean, it has no idea until, I mean, some programmer, all right, train me by their AI models, AI algorithms with large amount of data so that the model algorithm can inherently identify various patterns and make prediction just like the previous, examples we mentioned. All right. So we'll have more examples like this way. Don't worry. You want to teach Atik how to recognize different types of fruits like apples, orange, bananas. I don't know why mangoes are missing. I love mango. I never like apples, oranges, banana. Okay. So like coconut and mango and jackfruit, these kind of things are, I mean, wonderful. So I think we should change the examples. But anyway, so say you teach Atik how to recognize different types of fruit. Now, instead of giving Atik the robot a list of rules or instructions, which was before machine learning, before deep learning, there's a rule-based or instruction-based AI. Now you show him a bunch of pictures of each type of fruit. So when Atik, robot friend Atik, sees any kind of image or any fruit by its camera, which is just like eyes or vision. That's what we call computer vision. Like, I mean, take the image or video of any fruit. So sees more and more pictures. He starts to learn the patterns to distinguish each fruit. So it can learn how to separate and understand, just like in our real life. I mean, if you do not know what kind of things, like for example, before you move to China, Korea, or Japan, and if you don't have many friends from those region, it's very difficult for someone outsider to distinguish which one is Chinese, which one who is Japanese, who are from Korea. So because from outsiders point of view, all look alike. Similarly, I mean, my European journey is less, even though I visited many times, but still, I don't know. I cannot separate the nationalities very easily. Okay, but I was in Australia, so I saw lots of Turkish, I saw lots of Lebanese origins, so I can differentiate somehow. I lived in Japan, so that and visited China, Korea multiple times and met many people. So now I can differentiate more or less, but still, it's not easy. Like, can you differentiate? I mean, the Malay Malaysians versus the Indonesians. My friends who are living in Malaysia since long, they can more or less understand because their learning is good. they have lots of persons meeting or images and training, so their output will be better. In my case, it's poor. So you must understand that training with enough data, but good quality data, distinguishable data, so that your brain, human brain, just like human brain, a computer programmer can, develop some algorithms or models so that it can train the algorithm with lots of images or videos or text or whatever, based on the requirement, and based on this, the output comes. So eventually, the robot Atik will be able to identify new fruits without any further instructions, hopefully, not always perfect, just like human beings and so on. So this is similar to how machine learning works. So machine learning algorithms are trained on mid or large data sets. We want large data set, like many people want to be rich and lots of money, plenty money without working any hard jobs and so on. But the point is that large data sets are important, which can be images or maybe text or any other types of data. It depends on what kind of things. Like if you consider Siri, so it's not text, it's not image, it's taking your audio. All right. If you consider face recognition, then it's not about text or audio. Basically, it's collecting your video. If you consider gait or walking pattern understanding, then it's about the video or the silhouettes from the video and then processing them. So it depends what kind of data you need. So as the algorithm is exposed to more data, it learns to identify patterns and make predictions. For example, a machine learning algorithm can be trained on a data set of images of cats and dogs. This is a very common example. I have next lecture on cats and dogs. So if you love cats and dogs, then it will be easy for you to understand. After being trained on enough images, the algorithm will be able to identify new images of cats and dogs with higher accuracy. However, we have a lecture before that human learning versus machine learning, there are the shortcomings and good points and bad points and so on. I shouldn't say bad points. Like, I mean, limitations of, like, a human has some limitations, but machine learning or the AI models have some limitations as well. Now, let's look into the basic steps in machine learning. What are the basic steps? If I consider one step, what is it? Okay, the number one is the gathering data. Like, we need data, so data is the number one. Number two, learn patterns from those, so identifying similar trends, like, say social science, we had similar to identifying trends in social science. So we consider patterns, and then based on those learnings, we would like to make a prediction or learned information. So from now on, I will explain a bit more detail. Basic pipelines of machine learning process or pipelines of machine learning. Okay, what are those? So initially, data collection, like gathering relevant data, say customer purchase history. Then when we have data, we need to do in almost every case is pre-processing. So pre-processing means before getting the features, we want to clean. Just like if you buy vegetables from your garden, then you have to wash it, remove some of the bad leaves or distorted stems and other things. All right, definitely. So cleaning is important. Formatting the data is important. Like if there is duplicates, so no need to keep. If there are some missing values, like no values, non-values, then we have to remove them. Okay, or in our one of our research papers, we did not remove it. Instead of remove it, we did some kind of imputation, like assume that, okay, what might be other values because some data were missed wherever possible. It's easy for time series data, but if it's a hospital data, then I cannot put your data, your missing information with my information or others. It might happen that, okay, last 5 years, every month, once your blood pressure was measured, but in 3 occasions, randomly, those blood pressure information were not recorded, probably human mistake, or probably, I mean, auto mistake from the automation or sensor mistake or Wi-Fi problem and others, then how to fill those gaps or missing values? One option is remove those records. No need, because no blood pressure records are there. Another option is that we can consider, based on the previous records, we can assume that previous and the later one, we can just make it in like a average value, or instead of mean value, you can just consider some other steps. And so there are different approaches are there. Number three is the most important thing for traditional classical machine learning approaches, like feature selection. But in deep learning, many cases we don't need, I mean, separate feature selection processes. Okay. But sometimes we need feature selection, choosing relevant features. Say it might be like a customer purchase history. What about age, income, past purchases? So based on this, we can make a formative decision. When we have good data and process data, we calculate features or extract good features. It's very important that in life you can have, if you go to buffet, you get hundreds of different kinds of foods, but only, I mean, 5 to 10 items might be very good quality or you like them. So it depends what is important for you. So good features are important to extract. So feature selection is the key. Model training, using algorithms to learn patterns, like it can be in machine learning, decision tree or neural network, support vector machine, mm, boosting algorithms and others. So when we train, then we would like to evaluate the model. Okay, so it just like, I mean, before I go to the real match, I have lots of training with my coach based on different scenarios, and then the testing comes on a new data, new situation. So probably you are playing in England, and when you go to Pakistan or Bangladesh or India to play cricket, you face different kinds of, I mean, pitches and vice versa. So that's the thing. Like, I mean, you train in a situation to work well, but sometimes you go to, I mean, to be evaluated on a new data, new testing situation. And there are different like accuracy, precision, recall, F1 score. Okay, I read this kind of things we try to compute. When we find that the training was excellent and the evaluation, like testing result, is really good, we can consider, especially if you have work it for a project in a company or to develop something, you consider, okay, we are done, so let's make money. Okay, so model deployment. Okay, your startup company is now ready to deploy the model, implement it in real world scenarios like product recommendation system. So the from a customer purchase history data set, by doing lots of things, finally, if we find that based on that big data set, our training, based on the training, the testing result is good, then we go for model deployment, implementing it in real world scenarios and try to contribute to the community, to the world. And based on AI system, we make things better step by step. Okay. No work is finished. No work can be finished. If we say that, I mean, we have insulin and then diabetic is controlled. But is the insulin cheaper? Is it affordable for everybody? Does it have any side effect? What are the side effects? And how to reduce the pain? If you put the insulin via injections, can you do it just like a small tablet? And can you make it cheaper, affordable, no side effects? So it means that if you consider these kind of things, there are hundreds of extremely important areas for research, and these kind of things will go on and on and on. All right. So let's see those data collection, data pre-processing, feature extraction or selection, model training, evaluation or testing, and model development. These basic 6, 7, 8 steps in details now. The machine learning process, data pre-processing. So data collection and pre-processing are very important. Okay, because good quality data is important. So cleaning the data, removing outliers, okay, transforming the data into a format that the algorithm can understand. It may happen that you may have different sizes of images, but for the learning, we need 100 by 100 image, so that could be one option. So we need to convert all the images to 100 by 100. Yes. So these are the different things. If there are noises, so we need to do different kinds of filtering mechanisms and so on. If it's an audio signal, then say I'm talking, you are listening my voice, even if there are, I mean, car passing by, children are crying and so on. So then your attention should not be for those outliers and noise. But it may happen that sometimes noises are more, outliers are contributing significantly. Yeah, we have algorithms to remove those. So we can do that. Data should be cleaned and organized, much like preparing research data. So then is features. All right. So features means, I mean, we want to get the characteristics of data and remove unnecessary things or less important things, extract or consider better information. So feature engineering is extremely important, not election engineering. Okay. So feature engineering is the process of creating new features from the raw data. Now, features from input and levels output in a data set. So level means known outcomes. Now, when we have this, then say we have a data set of 1,000 images. Now, out of 1,000 images, we consider most of the images to train, because training should be rigorous. And then we test to rest of the, say, if 80% of the images are for training, then 20% images for testing. And we want to see that how much the training was done and the testing is showing good result. All right. So training and testing data, it's very important, and to understand the need to split data to training to train and testing set to see or test the performance of the model. Remember that usual process is training, then validation, and in not always, some cases people ignore validation, especially if the data set is relatively smaller, and then testing. So these are the three basic steps, but most importantly, train and test. Now, training test, if you just easy comparison, you can say that, okay, studying or learning, and test data means taking the real exam. So in another perspective, you can say that practicing or learning, studying for a sports match, and then facing the actual competition, probably in different environment. So, for example, your algorithm or model is trained or studied or practiced in a big hospital, but the algorithm, when it's okay, the testing is done based on the data from another hospital to see that whether it can, I mean, work nicely in a new environment, new situation, and so on. Because now the question may come that why models are trained on one data set and tested on another data set or hospital. It is done to avoid mainly the overfitting. Overfitting is like memorizing practice questions but failing to new questions, because if you consider known environment, then probably I'm very well known about these kind of things. Like I have been teaching significantly more than 2 decades, mostly in Bangladesh and a couple of years in Australia when I was doing my master's there. So I did here like HPL, or they call it casual academic, okay, like TA in other countries. Then I was in Japan and worked there and visited Japan in the last 20 years, every year and so on. All right. Now, 19 years, yeah, till now. So, Now, I mean, I have another experience. Now, if I move to another country and want to, because I have lots of training, if you consider as a teacher, all right? But in a new environment, it will be uh, more challenging for me, and my real test will be there. But if I teach in my known environment like Japan and Bangladesh, where I have more connectivity since long, I understand them. Then it might be like, I mean, what I know, it's my known environment, and my performance will be better. But uh, can my model as a teacher do the same level of accuracy or almost that level of performance in a new environment? So this is very important. Model selection. All right. So model selection and training is extremely important. Select an appropriate machine learning algorithm for the task at hand. Okay. The algorithm is trained on the pre-processed training data set, and when its training is done appropriately, that models or the model, okay, are done, I mean, to check in the real or another subset or testing situation. It just like practice versus actual performance, or mock exam versus real exam. All right. Now, in the model selection, then model evaluation. So, when the model is trained, it is evaluated on a held out validation or evaluation or test data set to assess its performance. And we have different accuracy matrices that we consider. Then I mentioned that when you feel that your model is running really good and you can deploy it in real life, okay, that would be wonderful. Like, I mean, and start earning. All right. So if you earn, share something with us. Now, I strongly recommend that you go to this teachablemachine dot with google.com. It shows different kinds of training and pose estimation related methods. Now, I copied here different machine learning process or pipelines, because different books or different materials, they have almost the same thing, but the pipeline or process looks different. Like, for example, data collection, number one, data pre-processing, and then model selection, and then training, and then model evaluation. And if the evaluation needs some kind of fine tuning, it's done, and finally go for predictions or results and production. So you see that, I mean, this is, I mean, one type of machine learning processor pipeline. What about this one? Almost the same, because data gathering means data collection, data pre-processing and preparation, model selection, choosing a model, training the model, training and gauging the model, like evaluating the model, and parameter tuning. Tuning means like, I mean, if there is slightly something to change, we can do. Now you see that this is another way to represent. Okay, so we have data. So business understanding, if there is any, then data understanding, data preparation and pre-processing, modeling, evaluation, deployment, or business understanding, we go feedback and so on. So you see, this is a circle. These kind of circles are representing machine learning process and pipelines and so on. These 5, 6, 7 steps are very common. This is another way so that you can understand better. All right. So again, the business understanding, like staging, pattern identification, business requirements, and data, like quality data, environment, data sources, data pre-processing or preparation, like labeling, preparation, and so on. Data modeling, of course, it covers the fine-tuning and training, model evaluations, and finally, model operationalization means, as we can see, deployment and so on. All right. So these kind of, I mean, things are more or less another way to show machine learning processor pipeline. So whenever you see a research paper or a new AI model, you try to first, I mean, figure out what are the common 6 or 7 or 5 steps, and how to differentiate those steps from one to another, and whether there are in between multiple subspaces or sub sectors that you need to understand. So again, this is another one like data requirements, data collection, exploratory data analysis, data preparation again. Okay, so the pre-processing stuffs are there, or feature extraction, model selection, and model evaluation, model deployment done. No, we do model tuning. So sometimes model tuning before, actually model tuning is done around these areas in most of the cases, and then or before you submit project review and so on. This is another one, data acquisition like data collection, pre-processing, hypothesis and modeling, evaluation and interpretation, deployment, and operations optimizations and so on. And based on this, we might have new data collections and so on. So this is another way to check that how a machine learning process or pipeline can be. So for example, fundamental data like big source, capacity, domains, entities, timeframes. This is learning data, training data, management data, retraining data, and so on. And the basic steps are there as well. So I mentioned this, our work at the beginning, that for autism versus typically developed children based on facial images, can we understand? So if again you see that this part, the top part is training, where we have pre-processing after collecting data, and feature extraction can be like handcrafted features or deep learning features. And then based on the true levels, the predicate levels, we compare and find the differences, how much gaps are there or lost there. And based on this, we update the weights and improve and improve and improve under multiple iterations. And then finally, that trained model is used or considered for new testing data set. All right. So testing means the trained model is employed to classify unknown samples. All right. That's it. So thank you very much. We basically covered a bit about mm, um, machine learning and uh, this kind of things. So we can stop recording.